over this problem because a lot of people missed it on like one similar to this on the quiz. So look up here, guys. You're still doing some bad things. So please start taking notes here. None of you cannot take notes. It was very obvious to me on the quiz that you all need to be taking notes. Okay. So every single one of you need to have something out ready to write down. Every one of you, or go to a different teacher's class. Get out. Go to a different teacher that doesn't require notes. That's one of my requirements. Okay. So looking at this, guys, I still saw people break the forbidden rule. Can I just go like this? Can I just go 3x squared and negative 2 squared? Can I just square that? No, that subtraction sign forbids me to do that. Because there's a subtraction sign in there, or an addition sign inside the parentheses, you can't do that. So what do we need to rewrite this as? 3x minus 2 times 3x minus 2. Okay, so some of you on the quiz got that far. And then guess what? You messed up after that. So watch carefully. I'm doing this for a reason. I was looking at the quiz and I said, okay, we need to talk about this. Okay, carefully now. We've got to multiply all this stuff to all this stuff. So we're distributing. Now, I'm going to focus on this 3x over here on the left and distribute it through to each term over here. So 3x times 3x is?
9x squared.
9x squared. Now, guess what half of you did? No, 80% of you wrote 9x on that, on the quiz. That's not right, guys. X times x is? X squared. So that's 9x squared. So hopefully some of you are going, oh crap, yeah, I did that on accident, and now you won't make that mistake in the future. That's why we're talking about this. So then 3x times negative 2? Negative 6x. Very good. All right, I distributed 3x through to each term on the right. I'm going to now distribute my negative 2 through. Negative 2 times 3x. Very good. Negative 6x. And then negative 2 times negative 2. Positive 4. Then from here, we'll go through and combine like terms. Now, those of you that forgot the x squared, you would have combined all those x's on accident, and you would have got the wrong answer. So just don't forget that 3x times 3x is 9x squared. Okay, combining my terms. No other x squared, so we still have 9x squared. I still have some of you saying negative 6x and negative 6x, they must cancel out. No, add them up. Negative 6x minus 6 more x's is? Negative 12. Good, negative 12 x's, and then we have our plus 4. And we're done. Okay, hopefully that helps those of you that made little errors not make them again. Okay, question on that. Ask. You have some of my top students last year scoring the highest on end of level, scoring the highest on the following year on their ACT test, were people who ask a lot of questions. So it doesn't make you dumb if you ask questions. So please ask. Okay, looking at this one was on the quiz as well, similar, not this exact problem, obviously, but there's a lot of people that missed it. So we have xy to the negative 3/2 raised to the negative 2/3. So we sing our song. When you multiply, you add. When you divide, then you subtract. Raise a power to a power, and you multiply the powers, right? Okay, so looking at this one, what's my, now this wouldn't be the forbidden rule. There's no plus or minus sign inside the parentheses. So we can just use properties of exponents and do it to both of these. Well, first of all, what's my exponent on x? 1. So there is an exponent there. Okay, so then we raise a power to a power and we multiply the powers. So raise a power to a power and you multiply the powers. So we're going to be multiplying 1 times negative 2/3, which is? Good, negative 2/3. So now some of you are not writing your exponents small. You're writing them like huge down here. Write them correctly. They're exponents. So we have x to the negative 2/3. Do you have questions on how I got negative 2/3, guys? Please ask if you do. Because sometimes I get going fast, so the question will help. So then negative 2, raise a power to a power and you multiply. So negative 3/2 times negative 2/3. You could use your calculator, use parentheses. What do you get? You should all be practicing on your calculators, not just relying on me, relying on a neighbor to do it. Positive, wait, what'd you get?
4.
Did you multiply them?
Yes.
With parentheses?
Yes.
Are you sure?
It's 4.
It's not 4. It is 1. So maybe look at what you typed in. Maybe typed it in where? Okay, awesome. Okay, so you got positive 1. True. Okay, so anyways, guys, then from there you have to go through and fix negative exponents. So I'm going to draw a line. I'm only going to flip things with a negative exponent. This has a negative exponent. I've got to flip it over a fraction. So we have x to the 2/3. Ah, it's so lame. I'm going to have to recalibrate. Does everybody see how I flipped it over a fraction? It's now a positive exponent. So it's gone, but I don't want you to write it like that. That's hideous. Write it pretty. So go off to the side. The y to the first is just y. So we have y over x to the 2/3. True? And we're done. We can't combine x and y. It's not like basics. Okay, questions on that? If you have them, ask. Okay, I gotta. Come on, little guy. I know you can do it. All right, here we go. Okay. Whoa. Quiz. 80% of you missed this problem. Then I looked at your homework. Well, no wonder. Half of you didn't do the problem. And then I looked at it, and then the other half did it wrong. No wonder. So we need to go over it. Here we go. So we learned this on Thursday, and we're building on it today. So if you didn't understand it, don't say, I'm just going to zone out. No, watch. I'm going to teach you. So look at this, guys. We learned about angles, and we learned all these different angle relationships, okay? And we used those to set up a true statement and solve for x. So let me show you what I saw on the homework and on the quiz. I saw people go like this. Okay, I see this. I'm 4x plus 150 is equal to 2x. Are those vertical angles? No, we have no idea if that and that are equal. If it would have been this angle, yeah, they would have been vertical angles. We have no idea if those are equal. That is not a true statement. Does everybody get that that's not a true statement? I'm not going to erase it. I'm going to leave it. Not true. Okay? So then we also learned that if we have a 90-degree angle, the sum of the two angles would equal 90 degrees. We learned if we have two angles in a straight line, on the straight line, then it would add up to be 180. So I also saw people like this. They got the 180 idea. Watch, please. Most of you made this error. Please watch. I saw people say, okay, straight line. 4x plus 150. This is what I saw 80% of those that did this wrong do. 4x plus 150 is equal to 180. So wait, you're saying that that little piece right there equals to 180? Not true. No, that's not true, guys. But all the way around, halfway around a circle is equal to 180. So what would a true statement be? Okay, yes, you're right. 4x plus 150 plus 2x, so that angle plus that angle, yes, you're right. That is a straight line, so it would equal 180. Does everybody see, oh, I might have been that person on accident. Oops, I didn't understand that on the homework, because yikes. A lot of bad scores on that homework assignment. Okay, then over here, now our goal is to solve for x. Let's combine all like terms first. 4x plus 2x is 6x's, and then we have plus 150, which is equal to 180. Now, piece by piece, guys. Now, listen, from here, some people just stop and say, well, I don't know what to do. Guys, we're trying to solve for x, so what should I do first? Beautiful. Subtract 150 from both sides. You're awesome. So we have 6x is equal to. Okay, now those added up to be 0, guys. Now I'm seeing people like this. Minus 150 to both. I don't know. It's just weird. Like we're subtracting 150 from both sides. So 180 minus 150 is 30. Very good. And then what? Divide both sides by 6. So x is equal to 5. Very good. Does everybody see how we set up a true statement, not just one we threw on the board, and then solve for x? Okay. And every true statement might be different, right? Okay, let's get to the new stuff. Here we go. Okay, so today we're going to be dealing with angles again, but we're going to be learning some new stuff. We're going to be dealing with parallel lines and a transversal. So we need to know what parallel lines are and what a transversal is, okay? So today, once we start practicing these, I think you'll think they're pretty fun. Make sure you're staying with me and taking some good notes here. Okay, parallel lines, guys, are lines that never intersect. So they're gonna also state it, just showing you. Okay, now notice these arrows mean these are the two lines that are parallel. You can know for sure they're parallel because those little like arrow-looking things. And then these little double arrows mean also parallel. Just depends on like the test or the teacher or the book on how they'll state that they're parallel. Or if they state it in words that they're parallel, then you can know they're parallel. So parallel lines are lines that never intersect. Now a transversal, this is a new word, a transversal. So a transversal is a line that cuts through two lines and is not parallel. So a transversal might cut through two lines that aren't parallel. It might cut through two lines that are parallel. As long as it cuts through two lines, it's a transversal. Now today we're going to be dealing with parallel lines in the transversal, so just keep that in mind. So I drew my transversal in red. Does everybody see how it's cutting through the two parallel lines? Yes. Okay, awesome. Now when this happens, guys, when we have two parallel lines and a transversal, a lot of really cool, unique angles are formed. Okay, so we're going to have all these angle relationships, and we'll be able to use them to, once again, solve for x, find missing angles, and yada yada. So notice we have two parallel lines and a transversal. We have all these different angles. Does everybody see how we have all these different angles formed here? And now we're going to learn about them. So a lot of angle relationships are formed here. Here's our first one. This is where you'll want to take notes, I promise, okay? Corresponding angles. So our first one is corresponding angles. So corresponding angles, they lay in the same position, exact same position, but they're on the same side of the transversal. So look at D and E. Do you see how they're in the same position on the same side of the transversal? But they're on different lines. So this line it's on this one, and then this one's on this line. So they lay in the exact same position. They're on the same side of the transversal. These are called corresponding angles. Does everybody see how that angle and that angle are corresponding? Okay? The rule is if you have corresponding angles, then they are congruent. So these two angles are congruent. Congruent means equal. So D and E are equal. Does that make sense? Now, this is the universal sign for congruent. It's an equal sign with a little squiggly above it. So if you see me write that, that just means they're congruent, which means they're equal. So now this one's the one with the most. We have tons of corresponding angles. So I want you to look with your eyeballs over at the colors over here. Look at the purple angles. Does everybody see how they're on the same side of the transversal and they're in the exact same spot but on different parallel lines? Purple. Do you see the purple angles? So they're corresponding. Then look at my blue angles. They are in the same position, same spot, but they're on the same side of the transversal, but they're on different parallel lines. Those are corresponding, meaning they're equal. Look at my yellow lines. Notice they are on the same spot. They're on the same side of the transversal and in the exact same position. So it's just different parallel lines, so they are equal. They're corresponding. And then green lines as well. So green angles, they lie in the same spot on the same side of the transversal, and then they are. All right, are we all good with corresponding angles? If you have questions, please ask. Okay, moving on. Alternate interior angles. These are the next one. Alternate interior angles. So alternate, guys, means they're on the opposite side of the transversal, meaning one's on the left of the transversal and one's on the right of the transversal. Anytime you have one, like two angles on opposite sides of the transversal, you know they're alternate. They alternate on each different side of the transversal. Does everybody see that? Now these are alternate interior, interior, because they're inside the parallel lines. Does everybody see how they're alternate? Ding, ding. And they're interior because they're inside the parallel lines. Alternate interior angles. If you have alternate, the rule is if you have alternate interior angles, then they are congruent. They're equal. So there's going to be two pairs of alternate interior angles on any two parallel lines in a transversal. So notice my blue angles here. They're alternate, meaning on different sides of the transversal. This one's on the left, this one's on the right. And then they're interior because they're inside the parallel lines. Alternate interior angles, and they're equal. Does that make sense? Look at my green one, angles. They're alternate. One's on the left, one's on the right. They're inside the parallel lines, so they're interior. So alternate interior angles, so we know that they're equal. They're congruent. Questions on that? Okay, last two, and then we'll just start practicing. And then from there, it's fun. So last two angles that are formed, and then we'll just start practicing. Okay, alternate exterior angles. So now if you're not understanding how to see these, you got to raise your hand and say, wait, can you clarify that or whatever. Okay, so alternate exterior. Once again, alternate means they're on the left and the right of the transversal, different sides of the transversal. So does everybody see how D and E are on left and right of the transversal, alternate sides of the transversal? And exterior means they fall on the outside. They both fall on the outside of the parallel lines. Does everybody see how that angle and that angle are on the outside of the parallel lines? Alternate exterior angles. The rule is, if you have alternate exterior angles, then they are congruent. They are equal. And once again, we have two pairs of alternate exterior angles. So if you look over here at my colored picture here, I have two black parallel lines, the red transversal, and then the blue lines are alternate. They're on different sides of the transversal, and they're on the outside of the parallel line, so exterior, alternate exterior. Same with the green. left and right of the transversal, and they're on the outside of the parallel lines. Alternate exterior angles, and so they're equal. Last one, and then we'll just start practicing. So last one, and then we'll practice here. Consecutive, or depending on who you ask, what teacher you ask, what book, what ACT test, they might call them consecutive interior angles or same side interior angles. So consecutive means one right after another. Same side means they're on the same side of the transversal, they're one right after another. So consecutive interior angles, guys, is they're on the same side of the transversal and they're inside, one right after another, and they're inside the parallel lines. So look right here. Does everybody see how this angle and this angle is one angle that comes right after another? Consecutive, E and D. Does everybody see how E and D are consecutive? One angle right after another. And then they're interior because they're inside the parallel lines. So consecutive interior angles. So the rule is different with these. These are the oddballs out. So odd man out, here they go. Consecutive interior angles, guys. They are not equal. They are not equal. Did you just hear me? They're not equal, but they do add up to be 180 degrees. So notice I drew D as a double line and E as a single line because they're not equal, but they do sum up to be 180 degrees. I mean, if we add up angle D with angle E, it would add up to be 180 degrees. So looking at this, these are consecutive interior angles. The green ones are, they would add up to be 180 degrees. The blue ones would add up to be 180 degrees. They're the only ones that aren't equal. Don't call them equal, even if they look equal. They're not equal necessarily. They do add up to be 180 degrees, however. Okay, that was the last one. Now we can just practice these. Yay! Are you ready? Be about ready. Here we go. Here we go. All right, here we go. So you're going to tell me, determine if these angles are corresponding angles, alternate exterior angles, alternate interior angles, or consecutive same side interior angles. So look over here. Now this one, I guess right here, I wouldn't suggest taking notes because it's going to be more beneficial for you to watch, and then you can practice on the worksheet. So I'd look up here and make sure you say, wait, I don't get why they're that, if you don't get. Okay, so make sure you're asking. Okay, looking at this picture, guys, tell me, what are they?
Alternate exterior angles.
So you know they were alternate because why? Different sides of the transversal, very good. And you said exterior because what? They're on the outside of the parallel lines. You're right. Alternate exterior. Questions on why those are alternate exterior? Very good, good, very good. Looking over here, guys, what are these? Why did you say they were alternate? They're, well, but why? Yeah, you're both totally on the right track. What I'm looking for, yep, you're both right. They're on opposite sides of the transversal. Beautiful. So they're on opposite sides of the transversal, meaning they're alternate, and then they're interior because they're inside the parallel lines. Very good. So alternate interior. It just really will help, guys, if I can help it like make the connection. So that's why I'll ask that. Okay, last couple, and then I'm going to set you free to work. Here we go. Are these alternate exterior, corresponding what? Alternate same side, what? Tell me. Consecutive same side interior angles. Very good. Does everybody see how they're consecutive, one right after another? They're inside the parallel lines, and so they are consecutive. Good. Consecutive interior angles. What do we know about consecutive interior angles?
They're equal 180.
They add up to be 180. Very good. They add to be 180. And what did we know? I'm going to write this because I'm going to make you guys on your worksheet. What did we know about alternate exterior angles? They're equal. They're congruent. What do we know about alternate interior angles? They're equal. They're congruent. Very good. All right. Oops. Last couple. What are these? They're corresponding. They fall in the same spot. They're on the same side of the transversal. They fall in the exact same spot, but on the different parallel lines. So you're right. These are corresponding. What do we know about corresponding angles? They're the same. They're equal. Questions on that? Okay. Last two, and then I'm going to set you free to work. Looking at these ones, which ones are these?
Corresponding.
Corresponding, you're right. Okay, how did you know they were corresponding? Same side as the same side of the transversal, and they fall in the same spot. So they're corresponding. So that means that they are equal. Very good. All right. This one's a little bit trickier. Think about this one for a second. Think about it for a second. Okay, ask your neighbor what they think that one is over there. We have two parallel lines and two transversals. So I want you to ask your neighbor, talk to your neighbor, which ones are these? Good. Hey, group 2, tell me what you got. Okay, so you said consecutive same side angles. You're right. Okay, so how many of you said that? Raise your hand. Consecutive same side angles. Okay, good. Now everybody look. Even though we have two transversals, does everybody see how if I took this transversal and just like threw it away, threw it off there, then we would have these parallel lines and this transversal, and these are consecutive same side interior angles, right? Still, does everybody see it? So these are consecutive interior, make sure you write interior angles. Now, what do we know about that then? They're not equal, but what do we know about? They add to be 180. Very good. Okay, any questions on that? Okay, practice 1 through 10 on the worksheet. Make sure you're writing what they're, like, even though it doesn't say to, I want you to write if they're equal or if they add to be 180. Ready, set, go. And while you do those, wake up. Okay, so the first thing we have to do is decide if they're consecutive angles, consecutive interior, alternate exterior, or corresponding angles. Okay. Okay, so looking at this now, we're going to actually apply our knowledge here. So the first thing before you answer it, you have to tell me, I'm just asking you to tell me, what kind of angles do we have here? So some more practice. So looking at this, we have two parallel lines and a transversal. First of all, before you answer the question, what kind of angles do we have here? You said alternate because they're on the opposite sides of the transversal. Very good. So alternate, and then what? Why'd you say exterior? They're on the outside of the parallel lines. Very good. Any questions on alternate exterior? And what do we know about them? They're congruent, so they're equal. So what is, if this is 100 degrees, what's this? 100 degrees. Very good. Questions? Okay, let's do some more. Bring it back to me, guys. You're going to need help on these if you don't watch. Okay, looking at this, before you answer what question mark is, what kind of angles do we have? Why did you say alternate? Opposite sides of the transversal. Good. And then what? Why'd you say interior? Inside the parallel lines. Very good. And we know that they are congruent. Very good. So they're equal. So if this is 30 degrees, what's this? 30 degrees. Does anybody have any questions? Some of you are still working on the worksheet. You need to bring it back to me. Bring it back to me, guys. Okay. Looking at this one, what type of angles do we have?
Corresponding.
Corresponding. How did you know they were corresponding? So they're on the same side of the transversal, and good. They're on both on top of the parallel lines. I like the wording on that. They're both at the same spot. They're both on top of the parallel lines. I actually have never heard it put that way, and it just makes total sense. Beautiful. Corresponding angles, and we know that they are congruent. They're equal. So if this is 90 degrees, this must be 90 degrees. Very good. Questions on that? Okay, we're getting down to the last few here, and I'm going to let you work again. You should be watching so that you're set to go. Trickier one here. Okay, well, before we just start going, what angles do we have?
120.
Okay, I want to know, before you even give me the answer, what angles we have? Consecutive, same side, interior angles, right?
Yeah.
Okay, and what do we know about these? They add up to be 180. They add up to be 180. So they add up to be 180. So how can we find question mark?
You can take 180 and subtract it by 120.
Beautiful. We'll take the total amount, 180, and we'll subtract 120. And what does that leave us with?
60.
60. So question mark must be 60 degrees. Okay, does everybody get that? Be careful. This was the oddball out. Okay, awesome. Work on problems 11 through 18, and then I'll bring you back to me to finish this up. Now, make sure you're practicing these and being careful, because when we start getting to the harder ones, you'll have to know what you're doing. Practices and did all of this just to get to here, this part right here. Now, many of you need to really start focusing right here and not work on the worksheet, because this is where the hard stuff comes in. This is where some of you handed in the worksheet and you didn't know what was going on. So please watch. So now we're going to be taking that knowledge, and now we're going to be dealing with some variables. Now we're going to be solving for certain variables. The reason that how we do this, guys, is the way we did it on Thursday. First of all, you have to set up a true statement. Now notice I said true. I said true in capital letters because some of you just randomly threw a statement on your paper, and it wasn't a true statement. And so you didn't solve for X correctly. It's got to be a true statement depending on what you're given. Also, then after you've set up a true statement, all you have to do is combine all X terms and solve for X. So once again, I'm going to ask everybody to not work on the worksheet, but to be watching and taking notes up here. Because I will not be able to handle the worksheet if you can't handle switching back and forth. Okay, so here's our first example. So it says solve for X. So given these two parallel lines and this transversal, we're going to solve for X. Well, to be able to solve for X, we have to set up a true statement. So I don't want the answer yet. I don't want the answer yet. Okay, before we can do this, I want to ask you, tell me what type of angles we have with this one. Corresponding, you're right. So what do we know about corresponding angles? They are equal, they're congruent, they're equal. Okay, so what would a true, so does everybody see that we have corresponding angles here? They fall in the exact same spot. They're on the same side of the transversal. They fall in the exact same spot, but on different parallel lines. You said that they were equal, so a true statement would be to say 60 is equal to X plus 30. Now ask if you do not understand what I just did there. So this angle and this angle are equal, so it's true to say 60 is equal to X plus 30. Questions on that? You can't just set up a random statement, it's got to be a true one. Now solving for X piece by piece, what do we do?
Minus 30.
Minus 30 from both sides, and we get
30.
So 30 is equal to X. Is X completely alone? Yes. X is equal to 30. Let's see if we got it right. Well, if we know X is equal to 30, then we can plug it in and check it. 30 plus 30 is 60. And they were supposed to be equal, and they are when we plug it in. So we checked our answer. Does that make sense? Okay, we'll just do a couple more, and then I'm going to let you work the rest of the time. So it'd be more worth it for you to stay with me and learn. And I will let you work the rest of the time. Okay. Looking at this one, we have 7x minus 20. And we have 2x plus 10 in these positions. Before we go through and answer this, we have to set up a true statement. Well, what type of angles do we have? How'd you know they were alternate? How'd you know they were alternate? Very good. They're on the different sides of the transversal. And then what?
Interior.
They're interior. How'd you know they were interior? Inside the two parallel lines. What do we know about alternate interior angles? They're equal, they're the same, they're congruent. So it'd be a true statement to say 7x minus 20 is equal to 2x plus 10. So that angle and that angle are equal. Okay, so now from here, guys, everybody listen. A lot of people on the worksheet, I can tell you got freaked out, and on the quiz, you're like, wait, we have a 7x on the left and a 2x on the right. I don't know what to do. Well, guys, we just need to combine like terms. But we can't magically float 7x and 2x together. We've got to perform the operation to get from one side to the other. So what should I do? Okay, so there's a couple different ways, but we definitely couldn't add 7x, because then over here, if we added them up, we'd have 14x's. Does everybody see why you can't add 7x to both sides? Okay, so somebody said add 7x. Well, that was a good one. I'm glad you said it. So I'm going to show you. What's 7x plus 7x? 14x. Did we get rid of 7x? No. So that was a good one, because we have to say, oops, on accident, I didn't do the right thing there. Okay. All right, so I heard somebody say subtract 2x from both sides. So I'm subtracting 2x from both sides. Now, some of you are not understanding what I'm doing here. We're combining like terms. What's 7x's minus 2x's? Positive 5x's. Now we still have our minus 20, right? Now over here on the right, negative 2x plus 2x is 0. So we got rid of it correctly. And then left is the 10. Questions? Now we'll do what to get x alone piece by piece.
Plus 20.
Good. We're trying to get x alone, so we'll add 20 to both sides. You're awesome. Add 20. So that leaves me with, on the left, 5x. Now look, those add to be 0, so I applied the correct inverse. So we have 5x is equal to 30. And now what?
Divide by 5.
Divide both sides by 5. Now 5 divided by 5 and becomes 1. So we have 1x, which is just x, which is equal to 30 divided by 5 is 6. Very good. Any questions? Questions? Okay, couple more, and then I'm going to set you free to work all by yourself. Looking at this one, we have x up here. We have this 4x minus 15. What type of angles do we have? Alternate exterior. Very good. They're alternating on different sides of the transversal, and they're on the outside of the parallel lines. Alternate exterior. We know alternate exterior angles are equal. So a true statement would be to say, now this one threw most of you for a loop on the last homework. When you see an x, you're like, well, then we don't have anything there. No, you have an x there. So we have x is equal to 4x minus 15. Joe, I know for a fact you need to be watching this, so don't talk to him. Okay. Continuing, guys. What? Thank you. Very good. Goggles and all. Okay, solving for x piece by piece. People are like, I don't know what to do. Well, we have an x on the left and an x on the right. They're like terms. Let's combine them, but let's combine them correctly. What should we do?
Subtract 4x.
Subtract 4x from both sides. Hey guys, what's negative 4x plus 1x? Look, negative 4x plus 1x. Negative 3x is over here on the left. And then let's make sure we did this correctly. 4x minus 4x is 0. So we have is equal to, and then what's left? So now to solve for x, so what's our last step? Divide by negative 3. Those divide out and become 1. So we have x is equal to, what's negative 15 divided by negative 3?
5.
Positive 5. Questions on that? A couple more, and then I'm going to set you free to work the rest of the time. Six x minus 3, 4x plus 21. Quick, stay with me. What kind of angles do we have? Corresponding. Good, corresponding. They're on the same side of the transversal, and they both fall on the bottom of the parallel line. So they're corresponding. They're the same angle. So we know that they're equal. So it'd be true to say 6x minus 3 is equal to 4x plus 21. Does everybody see how that's a true statement? Solving for x piece by piece, I'm going to move 4x over. What should I do to move it over though?
Subtract 4x.
Very good. Subtract 4x from both sides. Combining like terms. 6x is minus 4x is 2x's. So 2x minus 3, which is equal to, that added up to be 0, so I did it correct. And then this is 21.
Plus 3.
Okay, so then we'll add 3 to both sides. So we have 2x is equal to
30.
30.
Divide by 2.
Then we'll divide both sides by 2. So we get x is equal to 15.
It's actually 21, not 27.
Oh, you're right. Oh, okay, we better really quick fix here. So this is actually 21, you're saying. Okay, you're right. So 21 plus 3 is 24. So then divided by 2 is
12.
good. X is equal to 12. See, now notice it says find the angle in bold. You can't tell, but this is the angle in bold. So if we need to find that actual angle, guys, wouldn't we just plug in our x that we just found?
Yeah.
6 times 12, in parentheses, 6 times 12 minus 3. That would be our angle, which is 69. Very good. 69 degrees. So that's 69 degrees. What's this?
69 degrees.
69 degrees. Very good. Questions on that one? Last one, and then I said your free to work. Hardest one. Trickiest one, odd man out. Okay, what kind of angles do we have here? Consecutive interior angles. Consecutive, worst handwriting, so I'm trying to hurry. Consecutive interior angles. Now, is it true? Do not write this. This is not a true statement. X minus 1 is equal to X minus 3. Is that true about consecutive interior angles?
No.
Not a true statement. Don't write that statement. It's not true. If you solve for X, you're going to get it wrong. Okay, what is a true statement?
180.
What equals 180?
X minus 1 plus X equals 180.
Very good. So those two angles summed up, added up, equal 180. Okay, now let's combine like terms. What's X plus X? 2X. Negative 1 minus 3. Negative 4, which is equal to 180. So everybody see what I did there? Combine like terms. Questions? Solving for X piece by piece. Add 4 to both sides. So we have, I'm going to come over here. So we have 2X is equal to 184. And then what do we do to get X long? Divide both sides by 2. X is equal to 92. Very good. Now we're not done. It says find the measures of all the angles indicated. I don't want to find all the angles. Okay, so if this is if X is 92, then this will be 92 minus 1, right?
Yes.
Which is 91. Well, let's plug in X. So 92 minus 3, 89. Now those should add up to be 180, and they do. Questions? Okay, finish the worksheet, and I want you working until the bell rings. Do not put your stuff away until you're finished. Now check your answers with your neighbors. Check your answers with me. Make sure you're setting up a true statement.